Hey guys, this is Carson. Today we're going to be talking about LR circuits, or circuits with L, so an inductor and a resistor, which we know inductors are in units of Henry and resistors in units of ohms. So the first thing we need to know is the equation that we'll use to solve for this. So first of all, we'll use, using current, we'll solve with our initial current where we see that this equals the time over tau. And in this situation, our tau is equal to our inductance over our resistor. So we're going to do a quick practice problem with this where we'll find out the characteristic time constant for a 77.5 millihenry inductor in series with a 3 ohm resistor. So to do that, the first thing we need to do is just very simply is to use this equation here. So we take our 7.5 divided by 3, this would be times 10 to the negative third, which will give us our tau value, which will be equal to 2.5 milliseconds. And then using that, going back to this equation, we know that for our first unit of time, we can just set this equal to 1. So we can find our current when I naught is 1, or we can just take this out of the equation. We can do 1 minus e to the negative 1 with the negative carried over from our initial equation, which we know will come to, when you take this out, that'll give us 0.368 is equal to what we lose with our I naught. And so, so if we go back and plug this into that equation, we know that after 2.5 milliseconds, what is remaining of that? And so if we're trying to find the current after so moving on to the next part of the question, after 5 milliseconds, we want to know, after the switch is to move to disconnect from the battery, if the current being used is at 10 amps. And so after 2.5 seconds, we know that that's one period of time for the tau. So we take our 10 amps multiplied by 0.368 from our initial equation. And then in order to do this for 2 periods of time for 5 milliseconds, we'd multiply that by 0.368, which would give us an answer of 1.35 amps, which tells us that for, because an inductor, unlike a capacitor, it doesn't switch off immediately. So after the switch is turned off, it still takes, a certain amount of time for that current to go down in value and to eventually, complete the circuit, where we know that using this period of time, our 10 amps after that switch is turned off, will eventually end up as 1.35 amps after 5 milliseconds with this current. We see this much less than an RC circuit, which is much more common with a capacitor, with it being less practical in that sense. But there's a little example for you with an LR circuit. Again, if you just know these two equations here, that'll be able to help you to finish any of those questions that you might have. Thanks for watching, like and subscribe.